Okay, so I think we've got a lot of people that have signed on now, and I welcome you back to the final workshop for GOOD23, entitled Building a Digital Twin with Nature, and this is going to be very interesting for sure. So I just want to pass it over to Jonathan Brown, who is the facilitator for this conference. So without further ado, Jonathan, over to you.
Thank you, Yuri, and welcome everybody. And looking forward to this event. We had one in the morning here in Coburg, where I live, and we're going to build on that today with you participating in a conversation. So I'm going to introduce the agenda today. I'm going to introduce our guest speakers on the panel with me. And Steve here, Czajka, is going to spend the first 20 minutes defining what a digital twin is. And then we're going to go through 3 examples. One example around a project out of Europe and a digital twin project at a municipal level, looking at the subsurface and the surface level assets. Then we're going to look at an example out of the UK, a digital twin project related to their road system. Quite exciting. And then we will turn to a case study of Orlando, and we'll talk about that. And at the end of each of these sessions, we will open it up for questions. So be sure to cue your questions as you are listening to us talk, and then we'll open it up for conversation. And then we'll wrap it up. So let me introduce our speakers here today. Steve Czajka is the Senior Manager of Telus Business's Smart City Strategy. He has a degree in urban and regional planning from Waterloo and over 25 years experience in management, consulting, and development of municipal business solutions. I first met Steve when he was the manager of the City of Mississauga's Smart City program. They hosted a student climate challenge. And before that, he worked in the city's data and visualization studio, where his team built the city's planning hub that incorporated key elements such as GIS, open data, infographics, 3D visualization, and data science. Our second panelist is Raza Jafri. Raza joined me this morning, and I'm not going to go into that, and I'll save that for our conversation, what we did with the town of Coburg. Quite exciting. Raza is not the comedian from Los Angeles, right, Raza? But the same name he shares. He is a speaker as well, an investor, a global entrepreneur with experience building organizations from the ground up. He also has a degree in urban planning and sustainable development from Concordia University. Raza is the founder and CEO of MetaWorldX, his latest venture that builds world-class digital twin environments for clean tech and smart city organizations. Raza understands the importance of partnerships and using AI and machine learning to create meta worlds of our real world and that are environmentally sustainable. Steve is going to walk us through a 20-minute overview, as I mentioned. Please put your questions in the Q&A, as I mentioned. So I'm reading my notes here, Steve. I'm going to turn it over to you. Go for it.
All right. Well, welcome, Jonathan, Raza, and everybody online. So my name is Steve Czajka. I'm an OLS, specifically an OLIP. And what that means is an Ontario Land Information Professional. And I've got about 20 years of experience in GIS, data, open data, data analytics, data visualization, both in 2D and 3D, as well as, of course, a smart city and privacy, impact assessments, policy, and more recently in the ITS space and CV2X and digital twins. And so my digital twin experience is actually, virtually it's been pretty much my entire career, starting with GIS and 2D and then evolving that to 3D. And now more recently at Telus, I've been focused quite heavily on digital twins. And so I'm going to jump into that then. So let's advance this slide here. All right, so today I'm going to talk to you about a couple of things. One is as Jonathan mentioned, I'm going to talk to you a little bit about the definition of digital twins. But first, I'm going to talk about the types of digital twins that are out there in the marketplace today. I'm going to talk about the verticals that they apply to, as well as the features. I'm going to talk briefly about the architecture, not too much detail, very high level. And I want to talk about, more importantly, the future of where this is all going, and then, of course, how it ties back to open data. But before I do, I want to tell you a little bit about Telus. So Telus is an organization of about 70,000 people around the globe. We are a global organization. There's about 35,000 in Canada and 35,000 outside of Canada. And we're divided up into these segments here, as you see. Telus Consumer, which you would most likely see from your phone, your Telus Home, things of that devices. Telus Business Solutions, which is where I work in the smart city capacity. There's Telus Health, Telus Agriculture, and of course, Telus International. And so at Telus, we're really, in the smart city program, we're really focused on three big things right now. There's about 30 different areas in smart city, but we're focusing on just three right now. So it's transportation and roads, waste in the environment, and of course, safer cities. And I will say the biggest one is, of course, transportation and roads that we're focused on. So I'm going to give you a brief overview of this, and because this has a direct impact on how it plugs into a digital twin. So in terms of transportation and roads, we have products in market for things like smart intersections, and we're moving towards CV2X as a product. So cars talking to intersections, talking to pedestrians, talking to motorcycles, talking to cyclists, and so on. And we have a vehicle preemption, which means, fire trucks getting through an intersection quickly, all first responders, but also transit priority, because transit priority is very important for municipalities, both from a revenue perspective, but also from a climate change perspective as well. We want to promote that as much as possible. We also have products in smart parking, and they say that 30% of traffic is actually caused from people driving around looking for parking. So wouldn't it be great if they could just find that? And this solution is exactly just that. We have smart road patrol for detecting potholes, road assets, things of that nature, which is very important to the transportation, intelligent transportation play. And then, of course, we have smart fleet, and we own actually 3 different fleet companies within Telus for very specific things. There's also waste management in the environment, and a really great product for us today is actually smart waste bins. And this is also a huge environmental play, because you don't have to send your waste management fleet out every 2 days or whatever. They just get sent out when those bins need to be picked up, and it automatically routes them to those locations, which is fantastic. And then, of course, we have safer cities, and we're doing a lot in that particular area there. We have a number of communications products for first responders, and we're working on something called video aggregation and analytics, and nearly finalizing that. We're also doing mass alerting for cities as well. And so all of these things that I mentioned plug into digital twins. So let's now take a moment and talk about digital twins. So there's 2 main types of digital twins that are out there. First of all, there's real world and non-real world. We are focused just on the real world digital twins that have business applications. We're not focused on the non-real world sort of fictional type digital twins. That's not our area. And that's what we'll focus on today, is the real world digital twins. And so the basic definition of a digital twin has really just 3 components. The first one is you have to have a physical object, and that physical object could be an entire city, it could be an intersection, it could be a bus, a person, or whatever. And generally they fall under 3 categories: a person, a place, or a thing. We're focused on places and things. In terms of the second component is virtual. And so you need a virtual representation of that physical object. And that's where the name twin comes from. It's twin, it's digital twin. And then the third component is data that describes that digital twin. So an example that I could use is simply this. If you had, say, a street intersection, and at that intersection you had a traffic signal, Very simple example. That might be represented on a two-dimensional map as a dot. And that dot could be colored based on the color of the light that is in real time. That dot could be colored as, its condition. Maybe its condition is that light has failed and it's in flash mode. That light could be represented as its battery power level. It's at 70% backup battery, that type of thing. So this is the data that describes that. The physical object itself has to go through something called AECO, which stands for basically its life cycle from architecture to engineering to construction to operations. And that is usually represented in a geographical information system, a CIM, which stands for City Information Model, or perhaps BIM, which stands for Building Information Model. And then on the data side, there's many different examples of how this data gets represented. So we have to take into account IoT sensors. So this is like real-time data that could be camera feeds or just sensing equipment that's saying, this bin is like at 80% full capacity type of thing. It also comes from vehicle TCUs, so telematic control units that are on board a vehicle. Could be HVAC, could be localized weather, it could be credit card spending. These are all different types of various data feeds that can go into this. And it's literally unlimited in terms of what we can do. But we also have to represent or ingest, I should say, data in kind of two formats. There's the real-time format, but there's also your traditional format. And an example of a traditional format might be something like, we've received a development application at this particular address, and that will typically come from SQL Server or Oracle database that you have on site. So we can reuse all of that information that a city already maintains in their source system. So none of those have to be replaced. They just get ingested into this digital twin. All right, so some of the verticals that this exists in are quite huge. So transportation, transit, public safety, of course, the environment, smart city, there's a various amount of digital twin verticals that you can see here on the list. And there's also a wide array of features that I'm not going to go into these, but you got your basic visualization in both 2D as well as 3D. You've got analytics and KPIs like heartbeat sort of charts. You've got alerting. So if something meets a certain threshold, it can send you an alert. You've got timeline playback. Let's go back to yesterday. What happened yesterday at 3 p.m. right before that traffic accident occurred? What was the weather like? What was the conditions like at that particular intersection? These are all examples of what you can do. And some of the more advanced things are like beyond your situational awareness in operations. You've got this whole simulation play. So traffic simulation, pedestrian crowd simulation, lighting simulation, urban planning simulation, which is a fantastic application. What is this building or this new development complex going to look like before it's built? And how do our citizens feel about it? That's really, really critically important. There's lighting, there's solar and wind simulation, there's a number of different things. And at the very end there, I wanted to mention that there's also a huge educational component to those, because what a better way to learn about a city or a geographical space, like a campus or a mall or an industrial area, than by actually looking at real data. So today we're introducing Telus World. Telus World is one global platform as a service, PaaS offering. It's one core product. It's going to come in 4 different editions, and there's multiple expansion packs. So in other words, it's a single pane of glass for real-time operations, visualization, and simulation. And so the 4 product editions look something like this. There'll be a citizen version, which is a light version. It shows limited amount of information that citizens need to see to understand sort of what's going on. And then there's the internal version. So there's a version for executives, which is focused just on KPIs that you're trying to hit for the city. There's an operational view, which is much more detailed for operational managers in traffic and waste management, public safety perhaps. And then there's a pro edition, which is meant for your smart city and data professionals. And now I want to take you through kind of a high-level architecture, kind of the tiers of this sort of platform here. And I'll walk you through this from the bottom up. So the very bottom layer is connectivity. And this is absolutely critical for smart city pieces. And that's why telecommunications companies are very much interested in this. Because without that communications tier, you cannot adequately communicate real-time data from what we call the sensing tier into the intelligence tier. So the sensing tier refers to companies that we partner with, like Myovision, at the intersection, doing absolutely state-of-the-art product there. And that is sensing the intersection on a real-time basis, 24/7/365. And it has the capability to send that data into our intelligence tier. Same with Iris, Superfi, Genetec, and many other partners that we have. And we can continue to add partners as we go. The intelligence tier is really responsible for ingesting that data and making sense of it by using AI and ML and different techniques like that. This also includes GIS and those specialized data feeds that I spoke of earlier. And then finally, we have this experience tier. And this is the foundation for our product here. The experience tier comes as a core product that includes the basics that are fundamental to all of these verticals, which is GIS, BIM, IoT, visualization, search, and so on. But then sitting on top of these are vertical markets that we can develop over time. And we call these expansion packs. So we have one for smart city, transportation, urban planning, growth forecasts, and more. And as we develop this product, if we use something called a common data model, which means that all organizations would sort of follow that, similar to the GTFS concept, the General Transit Specification Fee. If we follow that kind of idea, but for each vertical, then we'll be able to share data between verticals, which is a pretty amazing place to be. So the example there is, your airports can start to share data with your transportation at a city level. So, if you had a couple planes land at the Toronto airport, suddenly it can share data with its nearby municipality. So you got 1,000 people getting off this plane, they're going to be taking Uber and transit and all these other things. You might want to modify your network, your traffic network, to adapt to that. And this is really the power of a digital twin going forward. And so there's one thing that I want to say here is that there's one common item that every IoT device on the planet shares, and that's location. Location is absolutely critical to our strategy for a digital twin. Everything's based on that. Whether that location is a fixed location at a traffic intersection, as I mentioned before, or whether that location is at a moving device like a truck or a vehicle or something. That proximity and that relationship is really, really important. So what we're trying to do here with the Telus solution is trying to aggregate existing fragmented and siloed data to convert information into insights, alerts, and actions. And that diagram on the right-hand side kind of describes that. You have the real world at the bottom, and that real world is sensing data. It's sending that data through the network into the cloud, into the integrated digital twin platform. And then finally, key managers and key decision makers can make really big decisions in terms of policy, in terms of bylaw, in terms of strategy, that ultimately impact and affect the real world that we live in. And this cycle of improvement will get tighter and tighter over time and improve over time as we go. And that's how we achieve remarkable human outcomes on that front. And so where is the future of digital twins going? So I believe that municipalities are going to see a huge increase in live data. They're used to transactional data through many different systems that they have, but that is going to move towards live data that goes forward. And I think cities are going to need to start to think about, and Telus is here to certainly help, with something called a common data model or an ontology, so that we can compare cities apples to apples, and that they can plug into things like GTFS and others as an example of what I'm talking about, but for every different vertical within a city. I think things will evolve to a game engine for sure. So Unity, UE5, different platforms like that are very powerful. And I think that's kind of where the visual sort of future of that is going. That will take a few years and a lot of investment to do that, though. I think it will be platform based. And what I mean by that is it'll kind of be like the Twitter of digital twins. It won't be one custom digital twin per city, but rather all cities will plug into one common platform, if you will. I think it will be a global scale. And I think the advancements that I'm seeing in AR, particularly Snapdragon, with glasses, I think that will usher us into kind of the metaverse as we go forward on that. And so what's the tie between digital twins and open data? So data is really what describes the physical world. And open data essentially does just that already. We've had open data now for at least a decade. And I think that's wonderful, but it will need to evolve though. So some of the future challenges, as I mentioned, the common ontology, I think that we're going to need to start federating our open data across all cities across Canada. I think that will be done through more of a data trust approach is my guess. And I think that we're also going to be confronted with live big data, but that is also open going forward there. And so what do we need to accomplish this, to kind of wrap up here? We're going to need 5G and we're going to need MEC in order to have these high fidelity sort of experiences through a digital twin, through AR glasses, that moves us into this concept of a metaverse. High speed, simultaneously, low latency kind of apps are really critical for this. I think that AR technology is going to need to evolve a little bit. I'm blown away with how far it is today. But I think that's gonna get better and better over time. And the time cycles we're talking about here is just a matter of years, not like 5 years or 10 years. In just a couple of years, you're going to see this mature. I think you're going to start to see the birth of a metaverse type platform that is based on GIS and BIM, that has high resolution sort of GPS that's powered by GNSS, sort of very high fidelity locational precision. And you're going to see these digital twins around the globe. There's no doubt about that. Every municipality will want one of these going forward, which means that we're going to need to increase the digital literacy of staff and people that are functioning and operating these things. We're going to need governance over this. We're going to need a legal transformation that deals with laws that go around the planet, and that's going to be tricky. And then, of course, we're going to need to see creativity like never before on Earth. The opportunities here to be alive at this time, at this place, dealing with this technology today, I'm just blown away with this and where this can go. I'm seeing a lot of years from a lot of people who've worked so hard on this over the years, and we're starting to see this transition happen. And I'm so excited about that. And of course, we need data and data professionals. So with that, I will close my presentation and open up for any questions. And Jonathan, I guess that's back to you.
Thank you. Yeah, that was wonderful. So I got a few questions, and then Nathan, are there any questions from the audience? We'll start with those questions first. Otherwise, I'll jump in. No. So
nothing currently, Jonathan. No.
Okay. Great overview, Steve. And you're definitely a champion of digital twins in the real world and the business case. We think that's important. We being people that are going to be living in these real world digital twins. The challenge that I'll put out to you is you talked about transportation and getting that real-time data, not just for fixed assets, but also for mobile assets. And then you talked about Google's, what was that standard?
GTFS. So it started with Google. It was called Google Google Transportation Specification Feed. GTFS, I think I got that reversed a little bit, but then it shifted over because Google sort of acknowledged the fact that they needed to open up that format.
Right.
So they simply changed the name to General Transportation Feed.
Yeah. So, I mean, Google Earth, and then we have Amazon Earth that Raza can tell us a little bit about. I think he's building off that platform. And one of the big problems I've heard time and again is interoperability across these big tech platforms. And I think we experience that on a daily basis. And then the other challenge I think I would put out is as we build this infrastructure, a lot of the stuff, the real world examples that we're going to look at is, well, what's the impact, not just on the transportation and the buildings, but also the environment in which that built up infrastructure is interacting with. So one of the questions would be, how Telus's environmental pillar will look at, let's say, reducing the greenhouse gas emissions for both the buildings and the transportation, because those are the two biggest ones for doing that. And then I guess the other question to throw out for conversation is and Greta would call this the the 21st century climate denial, which are the environmental, social, governance indicators. And the scope 3, you have to decarbonize not just the footprint of Telus, but you have to decarbonize the whole supply chain of the digital twin that Telus is going to be building. So I'll throw that challenge out. Maybe we can have a little conversation. Where do you see that going?
Sure. So we have, there's a number of different, so Telus, first of all, Telus is a very large organization. And so I don't want to speak for the climate group that works at Telus. I don't want to speak for a smart buildings group that we also have at Telus, but they're doing some wonderful things on that front. What I can speak to is the smart city aspects, which is where our team is. And essentially, within our portfolio, as I mentioned, we're focusing on 3 big things. Transportation is by far the largest thing in our portfolio that we're focusing on. So we made a significant investment in a company called MileVision recently, and MileVision has acquired a company I'll just mention here called it was a technology called SureTrack, and SureTrack is essentially making the flow of traffic more efficient. And the numbers they're getting off that are quite significant. So if you have this sensing technology at each intersection, it can better move traffic through your network than a traditional traffic controller and signal can. And, you know, we're talking like, this is like, I think the numbers are somewhere like 20% or something like that gains in traffic, which means you're not sitting at a red light, you know, burning carbon, or you're doing so less so, only when you have to, not when just because the traffic lights are doing that to you, sort of thing. So that's a huge advantage to cities. Not to mention as well, I mean, there's a big influx in the prioritization of transit itself. So MileVision also recently acquired a company called GTT, and they have a transit priority solution, which means your buses can essentially get a green light whenever it's possible. Not always, but in most cases. And so that means that will transfer more people out of the car into the bus when they know the bus can get there quicker. And that will also reduce the carbon footprint, which I think is just fantastic. So these are some really big needles that we're moving that don't even address, you know, I realize this is an environmental sort of digital twin session, but they don't, you know, this also has a huge play on safety as well through Vision Zero with V2X communication. So your vehicle speaking to everything. And that's a major part as well.
Okay, yeah, so let's pick up on that one. The other one you mentioned was the Internet of Things, and a lot of question around the Internet of Things and cybersecurity. And I did watch a webinar session on digital twins and cybersecurity, which was very good, and it was developed out of work that they did with the Boeing, and the military. It was very interesting, but that's the other thing. I mean, the Internet of Things. How are you at Telus looking at ensuring that the points that are talking to each other in that mesh data can trust each other?
Yeah, so there's 2 big things there. So you mentioned security, but there's also privacy. So I'll start with the privacy aspect first. So every one of our smart city products comes with privacy by design. In fact, we have a whole unit. I think we have the 2nd largest privacy office in all of Canada, second only to our federal government. And so that layer gets addressed first before we can productize anything. So scrubs it of privacy first. So that gets taken care of. And then we have another team, this is a whole team of cybersecurity experts and professionals that solve that type of problem for us as well in terms of security. I don't know all of the details and I don't want to speak for that team, but yeah, we got
Yeah.
you covered.
No, that's good. Now, I'm playing the devil's advocate, okay? So Quayside project, Civic Tech Toronto were really opposed to it. They were followed up on how Berlin sort of got Google kicked out Berlin. The biggest thing there was privacy, obviously. And I know that in the notes, the Quayside project draft that Sidewalk Lab Toronto produced was the issue of capacity of the municipality. So they came up with this idea that the libraries would be the neutral data trust holder of and protector of privacy. But what library has the capacity to do that? So the question then becomes, a lot of the big tech private companies have this capacity, and they're selling a product that requires similar capacity in municipalities or in public infrastructure, in public agencies or nonprofit organizations as well. And they don't have the capacity. So this is a supply chain issue, right? And unless that's addressed, I just wonder how you would avoid another Quayside project failure.
Yeah, so one of the things, so I can't really speak to the Quayside project. I wasn't involved in that. But one of the things that I learned from that was that the City of Toronto at the time did not have a policy in place regarding smart cities. So that's one thing that cities can do, is start to work now towards building a smart city policy. And obviously Telus can help them with that. But ultimately that's up to their council to sort of have that approved and move that forward. So hopefully that, I think if that gets solved first, then all the other downstream problems get sorted out as well. And there's other examples of issues like that around the world with some smart city things. But as long as you're focused, in my opinion, as long as you're focused on sorting out privacy right out of the gate, like before you even offer a product like that, everything downstream of that gets so much easier.
Okay, so let's, I don't see any other questions coming in. So let's go into our first example, and we'll build it back up from there. So if I can share my screen, and the way I'm going to do this is I'm going to show a few websites. And the first one is this one out of Germany. So it's quite interesting. My wife's German, so I have an extensive network over in Germany. And I'm going over there again in June. And I like to mentor young people over there. So I've got a couple of ones in logistics working for a company, and others working for a large private firm that is delivering e-vehicles to, they're switching from building gears for cars, so the German cars, to what will they supply with the transition to e-vehicles. Quite interesting. And then there's a young kid that's taking a course, and it's on digital society. It's an interesting course. So what you see here is you're all ArcGIS, any ArcGIS Online people will recognize that what we're sitting in here is ArcGIS Online. And you could actually copy this over as a digital twin if it comes up. Let's go. Here we go. So this is the 3D model in ArcGIS Online. And what you have here is the information. You can see Steve mentioned city information modeling, that is sort of an extension of the BIM, building information modeling, that architects are using. And last year at our workshop for Go Open Data, we had the PhD students from Carleton University, and they've actually created a 3D twin, a digital twin for the Carleton University that has both the subsurface and the surface, including the vegetation, well, the trees. So what you'll see here is you can go in and out and you can explore this, but the actual physical objects of that real world are accurately measured in this 3D model. And there you can see it's got the BIM model for inside of the building, and then on the outside of the building. And then they also will use things like LiDAR, and then they'll build in what are called levels of detail, not just for the buildings, but also for the type of soil underneath the building and the characteristics of the natural assets that are interacting with those buildings. And as we see more events, extreme events with climate change, one of the things that municipalities are going to be struggling to do is what's called resilient asset management. So in Ontario, Regulation 588.17 requires all municipalities to have a asset management in place by next year, and it is supposed to include green infrastructure, not just the gray infrastructure. Although what they're focused on right now is the gray infrastructure, the roads, the pipes, and the lines, and the buildings. So it'll be interesting to see with these different solutions that Telus and MetaWorldX and others are coming up with to help them to get this into a visual way in which you can begin to carpool in the different lanes and make decisions. But the other key thing is the ability to use these to create simulations of 100 or 50-year or 20-year storms, so that rather than building a stormwater system based on traditional knowledge or time series longitudinal data, what you can do is you can simulate, okay, what would happen with this infrastructure if we were to put a retention pond here, which may cost $2 million to build, and can we build a smaller retention pond so that the developers could put more houses up for density, and then can we manage that through what's called low impact development? So to do that, you're going to have a 3D model that shows the real world and captures the information from these flow gauges for water and for other aspects of the atmosphere, so you can predict, using AI modeling, predict what kind of weather is going to come up and proactively interact or intervene, say an emergency response or whatever it is. Now, I want to show you this example. This is one of the first digital twins in the developing countries. We know that most of the developing countries, or the least developed countries, whatever term you want to use, are the least responsible for climate change. So they, in the past round of the COP conversations, they won over the battle to get loss and damage from the developed countries. It's not what they had originally asked for, which I think was like 350 billion a year. I think they got 150 billion, if I'm not mistaken. But there's opportunities there. And so Grenada, which is a little island here, built their first digital twin. But what this is, it's not a digital twin, like you were saying, of the real world necessarily. It's more based on synthetic data, right? And the difference between the synthetic and the real is based on the physics and the real modeling of what's happening real time with those assets. So they worked on this digital twin, and the digital twin, bringing it back to Ontario, what I wanted to pull up here is this particular policy around low impact development. And it's open for comment until June the 5th. Not that you're going to say we need a digital twin to solve this, but what it is it's around the whole debate around Bill 23. And Bill 23 is about having more and more houses and more density. And if you're going to do that, then you have to figure out how to protect the environment so that the water coming into that built up area doesn't damage the area, basement floods, think of, and also that when it goes through into the creeks and where we get our drinking water, that the pollutants don't end up poisoning us. So this is a key challenge that we have to think about, and they are going to change the Planning Act. And so do you see opportunities here, Steve and Raza, about how the Planning Act might facilitate moving us from the meta world with synthetic data closer to the real world that Steve talked about, and how we might do that? Like, what would this look like if we were to start it in one small area to do like a minimal viable product of a digital twin that's affordable for municipalities to gain that experience?
Yeah, so I can speak first on that one. So yeah, so these types of digital twins that you're referring to are near and dear to my heart because they are urban planning. And this is a good example of why GeoBIM is so important. And so GeoBIM is really the fusing of a physical object like a building and the real world. So rather than having a building that's just off in space somewhere, it is now attached to the real world itself. And one of the examples that you had pinned on there was from Esri, and they have a GeoBIM sort of example there. Because when you think about it as well, even from a transportation standpoint, Next Gen 911 is going to be looking to navigate first responders, not just to the front door of the building, but right to the office, you know, on the third floor off to the side there. Like, this is where that technology is going. So GeoBIM fusing the buildings onto the Earth's surface, that's a great sort of example there. Using authoring systems like Autodesk Revit and things of that nature. I know that Esri also has an ArcGIS Indoors product as well that provides some amazing navigational ways to move sort of back and forth. And of course, they also have something new called ArcGIS Reality or 3D that I understand. So, and there's other companies out there as well. So there's Geocon that's digitizing the internals of buildings. And I think that's going to be important for large structures. And of course, Waymap, which also provides navigational services for people who have visual impairments. So that's really some incredible things going there. And so these do have a direct impact on urban planning. And they're starting to gain adoption. So in other words, urban planning has been using this. I've used some of these tools for, say, maybe 5-7 years ago. And that is just going to grow immensely, I think, over the future. So, and you're going to start to see AR involved in that as well. So right now, community meetings happen in a council chamber. You know, the future of this is your community meetings are going to happen on site. And they're going to be able to use AR and make comments right there on site before that structure is built. I think that's just kind of where the future's going.
Yeah, that's true. Raza, do you want to jump in?
Yeah, no, I completely agree with what Steve's saying. Essentially, as an urban planner myself, we found that, you know, LOD1 and using like base maps of, you know, what the building footprint in like a city like Montreal or a city like Toronto, what the buildings look like. We have the potential now to start doing simulations, and never before has there been this kind of technology available to us. So he's completely right. This is a very, very exciting time for cities, for municipalities, and for government. It's really important to look at digital twin technology and how we can help mitigate disasters, especially when it comes to nature. Our cities are densifying, sprawl is still an issue, densification, we haven't been able to nail it the way they have in Europe properly, but we are trying to look for solutions. So it's really critical right now for us to be able to, for people like Steve and myself to come back to the cities and be like, look, this is what we're learning in real world environments. These are the technologies out there, and this is how we can help better understand these complexities of natural systems and predict their behavior by using some of this technology that's out there. Using and building virtual models for natural systems, we can actually simulate different scenarios. So before we were using technology, you know, especially for understanding the built environment. Now we can use technology for predictive analysis. Rather than being reactive, we can be proactive on planning and city levels. So using these scenarios, these test scenarios, especially for a place like Coburg, where we want to start using this. And this morning, Jonathan, you know, you were witness to that. The students were just amazed with the type of technologies that are coming about right here in the GTA. So digital twins and combining that with geo information that's out there can help make better decisions for natural resources such as water, air, and soil. So this can help us identify areas that are at risk of ecological damage and develop strategies that can help mitigate that damage before it even happens. So completely agree with everything that Steve's saying. What we really, really need to understand fundamentally is there's a need for this, for us to expedite it, because what we do call the developing world, they're starting to use these technologies faster than we are, because we have a mature built environment. So it's even more critical for us to use digital twins, combine it with nature, help us better communicate the importance of protecting the natural systems to the public by providing a more engaging and accessible way of visualizing complex ecological concepts.
Okay, that's great. Now, based on that town of Coburg, Steve, back to you on business case for the real world. We are Public Works just finished their asset management for the stormwater system. We were spending, the taxpayers were spending $34 a year, and it wasn't enough to cover the cost, the life cycle and the replacement costs for the stormwater system. The total cost to replace it would be about $70 million for the small town of Coburg. And so the Watt and Associates said that we really should be charging the citizens $109 a year just for the replacement costs of the stormwater system. How could digital twins bring the cost down to manage the life cycle of the stormwater system and make it more resilient to climate change? If you can do that, then you'll get a contract from us.
Well, I don't know. Our focus right now isn't so much on stormwater, but I can tell you a similar case for roads. So we're working with a partner called Iris, and they have a product that scans roadway. And basically it's looking for deficiencies. And so instead of waiting for a pothole to grow and grow and grow and get larger and not only damage vehicles, but get to the point where you've got major repairs to a roadway. If you catch it early, you can repair it, no damage to cars and no damage to, or no need to reconstruct the whole road. So that's kind of the concept at a high level. And I'm sure that the same applies. I know my municipal experience, there's different scanning tools as well for inside of stormwater management areas using CTV cameras that crawl the network. So similar technology exists there.
So I'm wondering, like the town of Coburg has one GIS coordinator. She's very good, but she's one person. And where she's excited, she just got her drone license and got them to approve to buying a drone. So we actually have 2 licensed drone pilots, and the other one is the road inspections. But they haven't figured out how to use this skill set yet. And the other thing is, if the engineering department were to do this, they would probably bring in a consultant firm because they wouldn't have that expertise. So then the big question becomes, well, how do you provide opportunities for staff that want to do this kind of professional development and then align it to the strategy, the overall strategy of a particular municipality? I guess it comes back to that governance question, right?
Yeah, I can say so. One of the things, I'm also a citizen of Ontario. So one of the things I know is we have 444 municipalities in Ontario. That's a lot. And so that means that our municipal employees get spread very thin. As you mentioned, there's only one sort of GIS person in Coburg, and that's hard. So, and they've got public safety to look after, they've got planning to look after, they've got transit to look after, they've got an entire portfolio of things, snowplows, all this stuff. And it's hard for one person to do that. So what I can say is from my municipal experience is there are ways to partner with, that different cities can partner together with the private sector to get things that they wouldn't normally have been able to attain on their own. So for example, one of the things that I had worked on was an internet web mapping tool before that was really popular. And so we worked together with 3 different cities, and we actually built one of the first web browsers that had like a more advanced sort of GIS mapping as part of it. So similar business models like that can be applied to cities if they could group together and combine that with multiple cities working with, say, a larger partner like a Telus or something like that. So that can help.
Yeah, it's a real challenge because nobody told her to go get her drone license, right? This was their passion project. And it was a question, I think, of finding at the frontline workers that have these passion projects so that you can harness that, because that's going to be less expensive if you can harness that at the grassroots and not end up with 1,000 blooms, right? So if you can combine what you're talking about, collaborating. So a concrete example is there's a lot of flooding out of Fredericton in New Brunswick. And they got $100,000 to put together from Intact to put together a flood warning at the neighborhood level thing. And they're going to launch it this month. And I talked to those folks, and it was interesting because the civil engineer was talking to the city of Ottawa. That's how we got the person from the city of Ottawa to present this morning. And so there are these kinds of networks, but it's really hard to connect them up to be able to do something like this, because it's not cheap, right? You're going to have to figure out how to take this virtual and then put it on top of the real, and the real is full of legacy systems. And I know from our last workshop last year with the green button, that's another regulation 63321 in Ontario, where they're supposed to share the utility bill data with the customer's permission. So that stormwater fee, it will go on our utility bill. Then you would have access to standardized data if I agree to do that from my home. Then what you can do is you can begin to build these mesh networks and make it a two-way relationship between the property owners, the municipality, and the private sector. And then you can build a business case that's not going to break the bank. Because a lot of the cases, they might go out and they'll put it to tender and they'll get this digital twin, but then they'll have to send the staff out for training. Whereas if you get a passion project where she's doing this on her own and loves it, then you can align it to that kind of activity at the grassroots level. But I'm no wizard, so I don't know how to do that. But I think that's going to be a big barrier for digital twins. But hey, we've got to try, right? The other one we wanted to look at was the digital roads and the national roads. So let me just pull this up, share my screen. Where are we here? And then you're familiar with this one, right, Steve?
Yeah. So again, this is something that we're focused at Telus. This, not specifically this example, but just more generally the whole CV2X movement. And so part of that requires that you have an accurate sort of detailed road geometry. And so in GIS, over many years, cities have done a wonderful job in collecting road networks. And they use that for 911, they use it for snow plowing, they use it for a number of different applications. But it's only a single line sort of road network. Where we're moving towards is the digital twin of the road corridor, which includes very detailed sort of laneway, sort of turning lanes, traversals at intersections, collision points, ramps, and how they integrate with roadways, sidewalk delineation, cycle paths, bus stops, on-street parking, speed zones, and things of that nature. And what's evolving is smart cars. So smart cars are going to be talking to smart cities. And smart cars have this GNSS, as I mentioned before, that has, sort of decimeter accuracy within the roadway, which is incredible. And so this is really important. This virtual road piece is really important to be able to place that car within a certain section of a road so it knows, hey, I'm going a little bit too fast based on the speed limit that the city has assigned. And I'm now getting an alert from the CV2X technology in my car to inform me that the speed, I've gone a little bit over the speed limit on that front. Or maybe I've made a left-hand turn that's prohibited at this particular intersection. Like, there's all kinds of road rules in the Ontario Traffic Act that need to be digitized in order to create that incredible experience in the connected vehicle. So this is a great example of that. There's a couple of companies doing work in this area. So My Vision is doing some amazing work at the intersection itself, and they're basically coding the crosswalks at each particular intersection, stop bars, approaches, exits, so that they can count vehicles as they pass through those intersections, and count people and cyclists and trucks and different things like that, and have accurate measures like that. A group called TAC, the Transportation Association of Canada, is working on something called road data harmonization, which is a very similar initiative to this. I know that Esri Canada is working on things, many ITS solutions, from smart parking to smart biking to fleet, that are doing incredible things on that front. Of course, Iris, that I mentioned earlier, a partner of ours, is digitizing the roadway and has the ability to mark out your assets along the roadway. So here are all your bus stops, here are all your stop signs, here are all your traffic lights and various speed signs like that. AASHTO has created an AEGIST guidebook that defines the common data model for roadways. And this is very similar to something called NENA I3, which is a standard for next-gen 911 system. So we're starting to see digitization of 911, digitization of the road network, and digitization of buildings to connect everything kind of together. And another company that I'm just more recently familiar with called Geomate, another Canadian company, they're doing just that, and they are digitizing the roadway as well. And so this is an excellent example of further digitization of our physical spaces. So
yeah, this is kind of cool. I know Ontario Place is doing consultation. They're trying to do something like this. It's this is kind of a fun. You can have fun in this thing. Anyhow, yeah. So that's great. Raza, you're going over to a conference in the UK in June, are you not, on digital twins?
Yeah, so two conferences coming up next month. We're actually three. There's International Economic Development in Calgary. That's going to be a big one. So I'm going to be speaking there from Paris. We're going to be there with AWS, our partners at Vivatech, showcasing the digital twins that we're building in the Middle East, as well as here in North America, and the digital twin of Toronto that we've created, as well as Move. Move is the conference for transportation and mobility. It's in London. So we're going to be speaking there, talking about how these technologies that we're looking at over here, how can they help with public safety, improve mobility, and like we were talking about, increase efficiencies as well. So we believe that digital twins and this kind of technology can actually not just reduce costs, but it can save lives as well. And it's all about making that data come to life.
Yeah, that's great. So along those lines, let me see, where am I here? Well, I'll come back to that one. Oh yeah, how many have been to Orlando and visited the museum there called SNAP? And what SNAP can do is you can go, it creates augmented reality exhibits. So you can go out into different parks with your mobile device, and it projects those into that space. And they use that also to archive graffiti, for example. And so you can go in and you can be in that location and project it, and you can get access to that information, which is kind of cool. But that's Orlando. But really what we're interested in with Orlando is what Raza is involved with. So here's this announcement about Orlando and what it's doing with this development. And then Orlando also has its digital twin, unbelievably real. So Raza, tell us, what's Orlando doing that's trying to get rid of the unbelievable in that statement?
So we all know that, there's certain cities in the world that really like outdoing others. Orlando's interesting because what they've created is, through the Orlando Economic Partnership, they've created something called the Meta Center. And the purpose of the Meta Center, it's for attracting investment and ECDev. So just like we use digital twin technology for the purpose of, public safety and the environment, economic development is also a huge, driver for this kind of technology because, for example, MetaWorldX, we're going to be at Collision Conference because Toronto Global is having us at their booth showcase the digital twin of Toronto. Why is it important for ECDev in Orlando and ECDev in Toronto to have digital twins? The conversation is much more, is much deeper with digital twins. You're not just showing a picture and saying, hey, this is Toronto, it's a big city, look at the buildings. That's exactly what they told us. That's the conversation they used to have. With digital twins, now you can show where the accelerators are, where the academic institutions are in the city. You can fly around, you could show where the buildings, the new developments are coming, the real estate values. And something more powerful is, where do all the software engineers live? For a tech company like ours, it's so important when we're looking at opening our new office in Riyadh, in Saudi Arabia, it's important for us to know, where are the institutions that we could partner with? Where are the people, the software engineers, the data scientists? Where do they live around the city? That's how we're going to geolocate ourselves when we move into that area. So, what Orlando is doing, a lot of cities in the United States are now starting to look at, okay, there's so much data and information we have. How can we take that out of silos, bring it onto a geographic dashboard in order to run simulations? So Orlando is one of the cities, but there's a ton of them. Just coming back from Chile, with the Canadian Trade Mission, you know, the University of Chile and the municipality of Santiago, they're working on ways on how to increase ridership in their transportation network. Digital twins are a huge tool for them, because right now everything's on a dashboard, like CSV files going into a 2D dashboard, 2D map. Now bringing it into a visualization digital twin application. These are where the opportunities are, because you can run simulations. So what we're seeing happen here in Ontario, you know, it has global implications. Countries and cities, especially in the mining sector in Chile, they're looking at Canadian technology as an opportunity to streamline their processes. There's actually an entire mine in Chile that's using autonomous vehicles now. Those huge trucks that we used to see on TV as kids, and we're like, wow, those are being run completely autonomous now. So it's really important for us to be able to use digital twin technology, not just to monitor what's going on, but to simulate before we do it in the real world.
Yeah. Now, the other thing is I just highlighted the holographic display that they've talked about. Here in Ontario, I was at the open house for the Durham College Center for Innovation and Research, which is quite interesting. What they have is a mixed reality studio. And one of their applied researchers who we're hoping to get involved in our minimal viable product digital twin here in Cobourg, with the help of people like Steve and his company's Resources for Philanthropy, right, Steve? And then I know that Raza wants to help out because, hey, he thinks Cobourg's a great place. Anyhow, Harrison Forsyth, he's an archaeologist, self-taught, and he knows all this stuff. And he said, you know, Jonathan, it used to take me like 18 hours to render something. Now I can do it in 30 seconds. And I use cheap technology, photogrammetry. His camera is about 2,500. The lens he uses is $800. And he can go out and he can create a texture for a 3D model of an arena or any other building that you're looking at. And then it's got the geometry of that building as well. So that goes back to the BIM, building information modeling, inside the building and outside, and then the environment around it. So you can look at low impact development as we go more densely with our development and as we retrofit our old buildings. And by the way, 50%, well, I think about 90% of the buildings that will have to be net zero by 2050, they're already built. So it's not the new buildings, it's the retrofits that are the big challenge. And so you have to build a business case for those property owners to participate, because the municipality can't do it on its own. Anyhow, so that's the other one that we want to tap into, is the mixed reality applied research projects that municipalities can access. And that we've looked at that one. And then I thought this was a good one too. So one of the things you can do, this is the European Space Agency, and it has all sorts of examples if you want to go through this on their digital twins. And it's actually pulling in the satellite imagery and LiDAR data and the weather data. And I know from this morning, we looked at Hoskin Science. And so what used to, if you did this up in the Arctic, it would be $100,000. They have a $5,000 device, which is mobile, and it has 25 to 30 different sensors, parameters that you could measure with this. And then they have another one at about $950. And then they have one, which is like a Raspberry Pi put into a protective and weatherproof case for $500. So I said, can we take that and hack it and then create something that students could use to learn this? Could we attach it to that passion project from that GIS person? And he said, yes, why not? So that's what we want to look at. And then connect it into these big things. These big platforms from the satellite imagery it's all open data. So you can actually create a data cube using this satellite imagery, and then make it even more accurate with the Internet of Things and creating a mesh net, and then building in using blockchain to build the security around how this stuff all operates. And you can do it at a cost effective way, because if you don't build the business case, then don't bother going down this rabbit hole. Any other questions from the audience? I wanted to throw this up. This is an example of what we don't want to happen. They want to put sulfur into the air. So they actually convinced Mexico City to do this at one point. And the problem is this is the idea of reducing the heat from the sun. But if you stop putting the sulfur up in the sky, and that's what they're selling, the balloons that popped, right? And this is their way of marketing a solution that is not a solution. Then the actual, if you stop feeding the sulfur into the atmosphere, the impact is much worse than if you had done nothing. So we have to have controls over how this technology is used so that it's not done irresponsibly and an expensive mistake. So I'll stop sharing my screen, and I know that Yuri's going to put up a poll. I mean, I'm not surprised by this. When I talk to some people, do you know what a digital twin is? And they look at me as if I'm from Mars. But that's encouraging. Now we got 3 people that are planning to develop a digital twin. And then there are 10 that are not specifically, nothing specific defined as a digital twin. Steve and Raza, that's interesting because I think it goes to, they may have a key component that you need to make a real world business case, but they're not using the language that you're using. And they're not familiar with all these standards, right? So it's a question of finding out what language they're using and then bring them on board to asking the right things or being able to asking their senior management to do something that connects with what you're pitching to them from the outside. And I'll say the best deputy minister I worked for when I worked at the Ministry of Education for 17 years, he said, Jonathan, you have to ask 13 times. And what he meant by that is they have to absorb so much information that if he's hearing common language and he hears it he hears it 13 times, then he figures there's no risk because he's heard it 13 times. That was sort of his way of making decisions. And we're sort of in that front now. The problem is we're dealing with 2 disruptors, technology and the climate. And it's a race to figure out who gets that balance first, or the climate or the technology that's going to create sustainable, livable communities. So those 3 people, feel free to reach out to us. And they have our emails, right, Yuri?
No, but you can throw them up in the chat if you'd like.
I will do that, and I'll, let's see the others, everyone. I'll put mine in there. And if you want to see the results from, we recorded the session this morning on using emerging technology to adapt to climate change. And if you want, send me an email. I'll have it ready next week. And Raza, do you want to talk a little bit about what you showed the students this morning with the City of Toronto, and then what your challenge was with your connection there?
Absolutely. So when we were working with the City of Toronto right before COVID, the economic development officer, he saw the value of digital twins, especially for consultation purposes and for the ability to engage with the community and be like, look, this is for example, the Golden Mile project. This is how it's going to affect you. This is the opportunity. We had 23 projects lined up with the City of Toronto, and as soon as COVID hit all of those, you can imagine, just got shut down, and we had to, for the survival of the business, we had to pivot, and we pivoted to prop tech. So now we see all these powerful visualizations of buildings, of all these Tridel projects and stuff. We were working with all these companies because their physical presentation center shut down, and they needed to sell their units digitally. We were very successful at that, but I still felt that the opportunity is greater than that. What you see in front of you right now is what we're building in Saudi Arabia. This is for a project called Neom. And we are the front runners in this. We were up against Huawei, and we're actually building the landscape as we speak. So with our partnership with IBM, who owns the weather network, we have over 1,000 data APIs in terms of the environment there. So before a sandstorm comes, they're going to be able to see it in the digital twin and how it's going to affect their buildings. There's an external use for these digital twins and an internal. So it's important for them to be able to have these live environments that can actually show these applications. And for some of you that have not been able to see what the digital twin of Toronto looks like, I could open the live application, but this is essentially what it looks like here. So you could see, you know, all the streets, the infrastructure network, the subway system, the bike paths, and for different departments, they're adding different data that we're plugging into the system. So where the EV charging stations are going to be, their utilization, et cetera. I already told you what we're doing with Toronto ECDEV for Toronto Global to be able to show what the future of the city is going to look like. These are live IoT sensors that show live data. So live ground temperature, live humidity levels, all of that we're able to plug into our system. We're able to create digital twins of cities like this in less than 2 months. And in South America and the Middle East, that's where our focus is right now. For North America, here in Toronto, we're actually adding municipalities around Toronto as we speak. And they're starting to plug into the data that they do have. So coming back to the question of where do we start? Well, we start with what the cities and the stakeholders currently have, and where do they want to go? So you start building towards that, but building the visualization has been key. And we've been able to, when it comes to cost, process, and quality over the past decade, we've been able to refine it to the point where we could build these applications fairly quickly now. So that's just an example of Toronto. To the students this morning, we were able to show a live environment. So this, for example, is an example that we built in 2 weeks for AWS and Fireware. Fireware is an open, it's an alliance that allows open data to come in. And with our partners, Libelium, it's an IoT company, we were able to build this application, and the city of Cartagena, Spain, is using this as we speak for air quality. So over here, you're going to see this is live carbon emissions, particle matter, and we can override the system to change the time of day so it's daylight when we log in. So this is just an example of how quickly you could pull up data rather than a CSV file or a boring dashboard. You can start putting different data sets together in a visualization application. So this is what it looks like when you override it. We could change the temperature, the weather. You can start doing simulations that can impact that data. So that's what we did for Libelium and the city of Cartagena in Spain. And this is what we hope that in North America, cities can really start taking the data that they have and start utilizing it for running simulations, especially when it comes to environmental risk mitigation.
Yeah, along those lines, and if you stop sharing in a minute, just for what I'll do is I'll show them the one that Hoskins Science showed us.
Yep.
Because I think it's an important thing that we'll close on this point. Share. So what Hoskins were doing, I think it's this one. No, where is it? Nope. Here it is. Nope, that's not it. There it is. Okay. So what you're looking at here is a dashboard. So remember, Raza was talking about those sensors, right? So what they've done is they've got a demonstration farm down in the United States that they set up with all these sensors. So this is all real-time data that they're collecting. The parameters are there, the rain, the wetness, pressure. He explained PAR, but I wasn't listening, so I can't tell you what that is. It has something to do with photosynthesis. That was it. So it's actually a digital twin of a living plant in a way. And then all these other factors they're looking at. And now what you can do is, so this is real-time data. So going back to what you just saw with Raza, this would be feeding into what that visualization is doing. And then you could run simulations And what you want to do is you want to be able to take, so here's the data. So the data scientists, they like this stuff, right? The engineers, they like their contours. But common citizens, they like the visual. They like the metaverse, so to speak. They don't call it that, but they certainly like visualization. So one of the things is to take this kind of stuff and then engage the citizens in participating with this. So what we wanted to do with our digital twin proof of concept is to be able to create this mesh data, put some of these very inexpensive sensors out there, and then crash the models. Craig James is a civic engineer at Waterloo, and he uses supercomputers to test out the hydrological models. And he said hydrological engineers are not great coders. And usually what they do is they'll take an algorithm off the shelf and bind or twine it together and then throw it out there to do their environmental assessments. He said what we need to do is be able to look under the hood to see what algorithms they're using, and then begin to use standardized algorithms. And that comes back to Steve's point about standardization. So what they're doing is they're using what's called the Raven hydrological framework. So it's very similar to what Steve talked about with transportation. And you can do the same thing with buildings, plants, rivers, and other environmental factors. And then you can start to create a holistic real model of the built and natural infrastructure and how those relationships affect the way we live together in our towns, villages, cities. So this is kind of cool. The students were quite thrilled with looking at the fact that, hey, they might be able to spend $500 on not the most expensive one, which was I think $5,000 and mobile, but at $500, and then you could weatherproof it, you could put it out there. And what we want to do is connect it to the stormwater fee. So for Coburg, if they're going to jump my taxes from $34 to $109, I want to be incentivized to be able to use my property as an asset to support their resilient asset management. So I need to convince the engineers. I don't think I need to convince the planners, they're on board, but I do need to convince the engineers. So if you know any good engineers out there that want to help us out, you got my email. And thanks both Steve and Raza. This is great, informative, I think. And I will stop sharing my screen. Any other questions? Yuri, over to you.
That was great. Actually, I wouldn't mind hearing from each of the three of you. You know, what's the key points that you want to leave with us to take away from this workshop? Start with you, Jonathan.
The key thing, I think, is that we need to connect this to our formal education systems so that when they're coming up through K to 12 and post-sec, they're not graduating with theoretical knowledge, but they're actually graduating with experiential knowledge. What I mean by that is that they've actually looked at how to use these sensors, how to turn their communities outdoors and indoors into a living lab. And you may think I'm crazy, but a municipality of 5,000, Gibsons, BC, they did this. And what they did is they took the people with passion and they created job descriptions for those people and said, let's try this out and just see. And they didn't have to have a big business case to do that. They just tried it out. And then they learned through experience that, yeah, we need this, this works. So not only did they incentivize their employees, but they also were able to extend beyond their catchment boundary areas to be able to collaborate both with the post-secondary, with the private sector. And by that, they've been able to address a lot of the issues that they're facing with climate change.
That's great. Steve, how about, what's your key points?
Yeah, I've got 3 key points. One is working towards a smart city policy. And that policy doesn't need to be done, you know, city by city. It would be great if cities could kind of work together. And that's leading towards my second point, which is cities working together to adopt a common data model for different verticals within a city. And the third thing is government cloud adoption. In my experience, most municipalities, I would say the vast majority of municipalities across Canada are still on-prem in terms of data storage. And one of the things they're going to need to do to move forward on the digital twin space is cloud adoption. And so that'll be critical for them.
Okay, great. Raza.
Yeah, so I agree with both my colleagues here. Absolutely, cloud adoption is critical, and that's why we've realized as a tech startup that it's really important to work with some of the heavyweights out there. It used to be like if you're a small company, you're begging, you're looking for these large companies to pay attention to you and give you data. It's the other way around now. What's exciting is that they have so much data, they have so much information, and partnership networks. They're looking for tech companies, for startups that are movers and shakers in the space, and it's a big opportunity for you to take that information, to take that data, bring it to life, and bring it back to their stakeholders and their clients. And in that case, we've been very successful, especially with AWS and IBM, with their partnership network and the government. So I would encourage, especially students, to look into opportunities when it comes to data visualization, when it comes to data science and environmental technology, to be able to help mitigate future disasters, future risk, and reach out not just to companies like ours and Telus, but also to speak to municipalities, speak to your mayor, speak to your councillors, and talk about this, because this is it's something that's happening. Their climate action is needed, and Canada and the city of Toronto, for example, signed a deal at COP27 in order to hit net zero by 2050. We need to start taking more tangible results, tangible action towards reaching those goals.
That's awesome. Okay, so again, I want to thank all three of you. This was a truly interesting conversation, and much more to come in the future. We should all pay attention to the things that you provided us with today. So this completes the Thursday workshops for GOOD23, and I want to thank everybody that stuck it out to the end, because that was a hell of a lot of information that we got today, and it was very good, very valuable. So again, thanks to this workshop group, and I just want to remind everyone that we'll be starting up the conference day tomorrow at 9 a.m. So please join us again. Thanks, everybody. Bye for now.